Prime versus composite numbers. A prime number is a natural number, and recall, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, etc. But a prime number must be greater than 1, and it also must be evenly divided by only 1 and itself. So, for example, examples of prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, and of course there's infinitely many. But take 13, for example. You can only divide 13 by 1 or 13, so therefore it is called a prime number. Composite numbers are also natural numbers, and they have at least one divisor other than 1 and the number itself. So, for example, 4, 6, 8, 9, 10, 12, 14, and 15, and again, to name just a few. So if we look at the number 4, it is divisible by 1, it's divisible by 4, and another number, such as 2. The number 6 is divisible by 1 and itself, 6, and 2 more numbers, 2 and 3, and so on and so forth. You'll notice that all of the composite numbers, well, let's put it this way, all even numbers are composite numbers, except for the number 2. Of course, composite numbers don't have to be even, such as the number 9, which is equal to 3 times 3, in addition to 1 times 9. And you'll notice that 1 is not on either of those lists. 1 is neither prime nor composite. So I'm going to turn the page here, and what I want you to do is copy this page down, and I want you to circle all of the prime numbers. And once you've got that done, then turn the page and I will have the solutions. All right, let's see how you did. First of all, we already talked about prime numbers. There's 2, 3, 5, 7, and that's it for this row. And then we said that all the even numbers are going to be composite except for the number 2. So we're just simply going to put a line right through this and through all of these, because these are all even numbers, so we don't have to worry about any of them. Now, these numbers are not only even, but they end in 0, so we know that 10 goes into those numbers. All right, now going back and remembering our divisibility rules, let's see, 1 is not prime nor composite. 9 is composite. So let's see, 11 is prime, 13 is prime, 15, 25, 35, all these numbers down in this column are composite because they end in a 5, but 5 is prime. 17 is prime, 19 is prime. And now let's see, we've done all the evens, we did all the numbers that end in 5 and all the numbers that end in 0, and now let's talk about the rule for 3. Remember the divisibility rule for 3. You add up the numbers, and if the sum is divisible by 3, then the number is divisible by 3. So let's take a look at the number 21. If I add up 2 plus 1, it's going to equal 3. So 21 is composite. 23 is prime. 27, 2 plus 7 is 9. Nope, that's going to be composite. 29 is prime. 31 is prime. 33, that is 3 plus 3 is 6, so that's a multiple of 3. 37 looks good. 39, nope, 3 plus 9 is 12. 41 is prime. 43 is prime. 47, that's prime, but 49 is not. Now that's not a multiple of 3, 2, or 5. It's one of the special ones. It is a multiple of 7. 7 times 7 is 49. We do have a rule for 7, but it is so complex it's just easier to just know that number. 51, one of my favorites. 5 plus 1 is 6, so that is composite. 53 is prime. 57, another one of my favorites. 5 plus 7 is 12, and therefore that number is composite. 59 is prime. 61 is prime. 63, nope, 6 and 3 is 9. 67, that's a good one, that's prime. 69, 6 plus 9 is 15. 71, that's prime. 73 is prime. 77, nope, that's one of those funky 7 ones. It's 7 times 11. 79 is prime. 81, 8 plus 1 is 9. That's a multiple of 3. But 83 is prime. 87, add those numbers. 7 and 8 is 15, so that's going to be composite. 89 is prime. 91, okay, now that's a real tricky one. 7 happens to go into 91. Let's just do it right here. If I divide that by 7, it's going to go 7 times 13. So 91 is probably the hardest one in this entire page. It is composite. 93, 9 plus 3 is 12. 97, that's prime. And 99 is composite because 9 and 9 is 18. So, how did you do? This workforce product was funded by a grant awarded by the U.S. Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the United States Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites and including but not limited to accuracy of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.